Hello, my name's Roger Watson, and in this session we're going to look at a Mokken scaling analysis, and I'm going to walk you through one. And what we're going to analyse in this session is the What Nurses Need to Know questionnaire, which is composed of 15 items. This is a fictitious questionnaire based on real data collected for another purpose. So the data are anonymous, the questions have been made up, so let's see if there's a Mokken scale within these data. So what you have available to you is an SPSS file with the data on it. You can see the 15 items here, and you can see that the scores range between 1 to 7. 1 means nurses don't need to know that, and 7 means that they do need to know it. The precise scoring here isn't too important. This is just for the purposes of illustration. And we can scroll down to see how much data we have here, and we've got over 400 participants who've responded to the questionnaire. The software R doesn't use SPSS files, so you have to convert the SPSS file into a file that's readable by the R software, an R data file. So I'm going to talk you through that now. So first of all, open up R Studio. I've put it here full screen so we can see it clearly, and I've scrolled this across to give us as much room here as possible. You can see that there's syntax here on the right hand side. This is syntax that I've stored from a previous analysis, so I'm cheating slightly here. I've already gone through this and I have the syntax here, so I don't actually have to type it in. I can just click on it and it will appear in the working space on the left, and a carriage return operates the command. So the first command that we're going to enter into the R Studio is library foreign, and this installs a package called foreign, which allows you to import data that are not R data into the R database. So I'm going to get R into the workspace on the left here by simply clicking on library foreign over here and doing a carriage return. You can of course type the commands in here if they're not here. And when you do the carriage return, it brings up another of these greater than signs, which is the sign within R that you can type in more syntax, and if that sign appears with a flashing cursor, it means the previous command has worked. Of course, when you enter packages, you don't usually get any results here. So next we're going to type in this rather lengthy and clumsy looking piece of syntax. You can see just how difficult the R syntax is. It's difficult to remember it, but what we're going to do is create a file called file R, which is one we can work with within the R package, and we use this command data frame, and it reads an SPSS file and finds it on the drive where you've stored it, in this case on the G file. You do need to know which drive your files are on, by the way. So it finds this SPSS file and creates this file R from it. And as I say, that file R is one that we can work with in the R package. So I'm going to find that command here. There it is there. Double click, and that goes in to the working space here. The file is called WNNTK, what nurses need to know, save file. Do a carriage return, and that converts the file into a file that we can work with. This particular set of warning messages here you can actually ignore. They don't affect the outcome. I've never actually found out why these come up when you convert SPSS files, but I haven't been able to get rid of it, and I have consulted some experts about it, so don't worry too much about this particular error file. The next thing we need to do is to load the package Mokken software. So you type in library, open brackets Mokken, and close brackets. We could have done this at the beginning of the process. It doesn't really matter when you do it, but it's in there for that session whenever you do it. So library Mokken brings the Mokken package, which is already installed on your computer, into the R software, where we can use it for the rest of the Mokken scaling analysis. So I'm going to find library Mokken over here on the right hand side, double click, carriage return, and that's it loaded. And when it does load, it tells you which parts of the package have also been uploaded, so it gives you some output there before it comes back to the flashing cursor, which means you can proceed with the analysis. The first thing you want to do in a Mokken scaling analysis is to find out how many scales there may be in your data, and to do this we use the automated item selection procedure, AISP. There are other ways of doing this, but this is the most common and by far the easiest to use. So you type in AISP, open brackets, file R, which is the name of the file you're working from, and close the bracket. So I'm going to find the automated item selection procedure on the right hand side, double click it and do a carriage return, and here we see the outcome. The items in the scale, all 15 items, appear in order and they have a number next to them, 1, 0, 2 or 3. 0 means that the item doesn't scale, and the others mean that they load on particular scales. So there's a scale of 1, 2, 3, 4, 5, 6, 7, 8, 9 items loading, as it were, on scale 1, or clustering on scale 1 might be a better way to describe it in Mokken scaling. And then there's a couple of items in 2 and a couple of items in 3, or 3 items in 2, but anything less than 2 items doesn't constitute a Mokken scale, and a very small scale comprising of 3 items is probably of little interest to us. So what I'm going to do is focus on the items which clustered on the scale 1, the first scale, which is the biggest scale, and it's always the one that comes out with the most items on it, the one that's numbered 1. So I'm just going to assume there's one scale here and carry on the analysis from that point. So the next thing we need to do is to create another file with only the items numbered 1 in that file. And to do that we use this syntax. I'm going to create a file, file ry, just to differentiate it from the parent file, file r, and we put in a command like this by opening square brackets, space, comma, c, opening brackets, and entering all the items that we want to save to the new file. So I've already prepared one earlier. Here it is with those items in it, only the items that we want to analyse. It's up here, sorry. I'm going to double click on that, do a carriage return, and you get back to the cursor. It means that that file has been created and is ready to analyse. The next thing we want to do is to see if there's likely to be a Mokken scale in those data, and for this we type in coefficient h, which generates a Mokken scale, and the name of the file in brackets. So I've got that syntax on the right hand side here, so I double click on that, do a carriage return, and there we see the outcome. It gives us the item pairs and the h value between them, the h value of each of the individual items, and the h for the overall scale. And we can see that it seems to be forming, at the moment anyway, a very strong Mokken scale. The next thing we want to do is to check the monotonicity of the items that are contained in that scale, and we can do this with this very quick one-line piece of syntax. It gives us a summary of the output of the extent of monotonicity in the items that we have in file ry. So I'll find that command here, summary check monotonicity file ry, double click on that, carriage return, and what we get here is an output which is very encouraging. It's really the crit values we want to look at here. There are no significant violations, and this crit value here of 16 for item 4 is very small indeed. So the items are all the items show monotonicity, which is good. We don't have to remove any items on this basis. Now, before we go any further, we want to have a look at the items and inspect the item pairs to see if it's worth going on to do an analysis of invariant item ordering. So this is the syntax here. Again, it's rather clumsy. I want to miss out the plotting of the confidence intervals because that rather messes up the output. So anything where you see a plot or any command equals false, it means that the R program isn't going to do it. So I'm just going to plot the raw pairs of item characteristic curves here. So I find that piece of syntax, the plotting syntax, here it is here, double click, carriage return, and it gives you a command at the bottom here which says hit return to see next plot, and I've clicked plots here in the bottom right hand space, so as I do a carriage return we can see the item pairs plotted out here. I'll run through these fairly quickly. What you're looking for here is items that are lying very far from the rest of the cluster, or lots and lots of intersection between items, and we're not getting that so far, so that suggests that these items, there's some intersection there but it's not too severe, are suitable for analysis of invariant item ordering. These items which are very close together, intersect, will probably be picked up in the analysis and we can probably remove them. So I've got to the end of all the plots because the cursors appeared a few times there. So we're going to proceed with an analysis of invariant item ordering. Now you can plot IIO results as a summary, a bit like the monotonicity, but this, according to an expert colleague in the field, doesn't give you the best output. So the best output is to use these two lines of syntax. That's the first line and that's the second line, rather long and clumsy piece of R syntax. So if you type the first line of syntax, I'll just go back to it and then do a carriage return and then type that and do a carriage return, you get the correct output for invariant item ordering. Please note it doesn't actually calculate the invariant item ordering, that can only be done by visual inspection. It gives you a value of H-trans, as we'll see. So I'm going to find that syntax here. I'll double click on that piece, do a carriage return, nothing happens, and then do the summary, and I get this output here which shows us a very low level of accuracy here. HT is very, very low indeed. However, there are significant intersections between items here, and the next step that we need to do is to start to look for the most significant intersections, and if they're all the same, choose the one with the highest crit value. So what I want to do is create another file and reanalyze the invariant item ordering, removing item 4 because that's the one with the same significance level as the other items with the highest crit. So to do that, I'm going to create another file ry with item 4 missing. So I can find that piece of syntax here with item 4 missing, double click on that, do a carriage return, and then run through the IIO results again, using the same syntax as before. And we get this output here. There are still significant violations. The highest violation is item 13, which has got the crit of 78. So what I want to do is then create a file without item 13 in it. So again, I've got syntax already created, do a carriage return and run the analysis yet again, and there we get no significant violations, very low levels of crit, and we can see that the value of HT is still below the lowest acceptable level for accuracy. It's only 0.207. So now we have a set of items that forms a Mokken scale, and there are no significant violations of invariant item ordering in them, albeit that the accuracy is quite low. What we want to do next, something we haven't covered previously in the program, is to check the reliability of that scale. And the reliability is checked with something that's very similar but different from Cronbach's alpha, but it's a single sample measure of the internal consistency of the data in terms of Mokken scaling. So we'll run this next. So to run the reliability, I take a look in the syntax here to see if I've done it already here. There we are, check reliability. Double click on that. It says file R, so we need to change that to file RY, carriage return, and then we get the reliability of these items. Anything above 0.7 is considered to be high. It's the top value that we look at here, it's 0.91. It also gives you the alpha and another kind of reliability there. So the scale is reliable, but I must warn you that similarly to other scales using Cronbach's alpha, most Mokken scales are reliable. The very useful step is to work out the mean values of the items that are left in the scale, and we use this command here, file, name, comma 2, comma mean, all within brackets with apply as the command. So checking the syntax on the right to see if I've already done this. I see I have. It's here, apply, file R2 to mean, double click on that, carriage return, and this gives you the mean value of all the items that are left in the scale. It doesn't give you them in order, it gives you them in order of the items, not the mean values. Once you've gone to the bother of creating this file, the one that's the file of interest with the Mokken scaling items in it, you may want to use it again. So the thing to do here is to use this long command, which is a save command. You name the file, you want to save it as a file in the G drive and as an R data file. And that's the command whereby you can save it to a known drive, and then it's very easy when you come back to doing further analysis to then retrieve it using this very simple command, which is load the file from the drive onto the R program and into the Mokken scaling program if necessary. So I'm going to find some save syntax on here. I've got some up here from a previous piece of work. Double click on that and it ends up in the working space. I need to relabel the files with their appropriate name. So even if you're not pasting the syntax directly and using it that way, it's very easy to adjust it. And when I click on that, I get back to the flashing cursor. That means the file has been saved. And if I use the load command, as I showed you a few minutes ago, then I can get the file back up again to work with. But the file is still on the system at the moment. It's on there until I close down the R software. Before you finish off your Mokken scaling analysis and close down the program, you may want to save your item pair plots as a PDF. You may want to use these to check them again or to incorporate them into a publication. You don't want to go through all the process of having to generate them again. So first of all, you have to name your figure and give it a name. Here I'll call it file R, and it's going to be saved as a PDF. You have to set the drive to which it's going to be saved, in this case G. Then you have to specify that the name of the figure will be a PDF. And then finally, this long and unwieldy command allows you to save the plots. I've turned off the confidence intervals, and you also require this other command here in order to be able to save it as a PDF. And finally, when you run that, you finish off the process by typing in dev.off, open bracket, close bracket, and the file should be saved with the appropriate name to your G drive in this case. And so back to the Mokken scaling program. The syntax for saving files doesn't appear here, so I'm just going to paste it in here from some saved syntax in a Word document. First of all, I'm going to paste in name of figure and state that it's a PDF. Do a carriage return. Open up my saved syntax in a Word document. Then specify the drive as G, carriage return. Specify that name of figure is going to be a PDF, carriage return, and then the actual file which saves it. I'm going to use this one down here because I don't want to save the confidence intervals. Carriage return, and that should save the file to your G drive and then you just need to finish the process off with this command here. Then you see this space and a 2, and the flashing cursor comes back up, and that means that the file has been saved to your G drive. So then we can check to see if it is actually saved on the G drive. I brought up the G drive here. Hope you can see that we've got the original SPSS file and the R data file generated from that. Then we've got the final R data file here with the Mokken scaled items in it, and then this file here is the PDF of the plots. I'll just click on that, open it up to make sure. There it is. And that completes the Mokken scaling analysis. You can save all the syntax either by copying it and pasting it into a Word document, or by saving the file to another file under any name you wish. But you don't really have to do that unless you want to present all these syntax, for example, as supplementary material in a paper. All the syntax that you've used is here if you don't want to happen to go back in and do the analysis again. So that's the Mokken scaling analysis complete. And finally, what does this look like when we present the data? Well, I've presented a fairly attenuated form of the data here. It's conventional to present all the data and to give all the mean values and all the H values and not just focus on the items that came out, but here, just for clarity, I'll do that. So we got 1, 2, 3, 4, 5, 6, 7 items that were included in the Mokken scale and which showed invariant item ordering, although, as I point out, HT was only 0.21, so it's not very accurate. The items are very close together. You can see that from some of the mean values here. And the HS, that's the scale H, is 0.62. That's for these items only. We didn't actually run that in the analysis. I went back and did it just to check. So you can see that it's very high for the scale, and the reliability is 0.91. So that's one way to present the data, with the mean values and all the H values, and it's now conventional to give the standard errors as well, but I'm not doing that here for clarity because we're not going to actually use the standard errors for anything in this particular course. If I flick down here, what I've done here is I've arranged the items according to their mean values, and this is the fun of Mokken scaling. This is where you find out if the Mokken scale actually means anything. Higher mean values here mean that people ascribe more importance to them. So the most important thing a nurse must do, of course, is turn up for work. Then they're expected to behave professionally, and we'll jump down to the bottom of the scale here. It's not considered so important that they must be able to plan care for a patient or organise the care of a patient according to this particular scale. But please remember, the items here are attached to a completely different set of data. The items are fictitious, the data is real, but they bear no relationship